Okay, so I want to take a look at an example that kind of let us do a little bit of algebra. I know we're all itching to do some math finally in this stats class. So let's take a look and see what's going on here. So example 4 talks about it's on page no, on the page. It's like 150 something. But so example 4 talks about a situation where there's a college and they have they want to compare the SAT scores of the students before they come in, and they compare that with their first year GPA after they're at the school. And so they want to see if there's a relationship there between the your your SAT score before, like when you're applying to go there, and then what your GPA will be the first year you're at the school. So what they did was their X value, their independent variable was the SAT score, and their Y value was your GPA. So they're trying to see, can your SAT score before you come to the school be used to predict what your GPA will be once you've been at the school now. And so what they did was they had all these values. So they had all these values in here for the SAT score and all these values in here for the GPA. So what they did was they took all these SAT scores and they came up with an average, with a mean, and they called that X bar, which in this case it was 649.5. And then they took, and they also found the standard deviation. They called it SX, which was 66.5. Then they took all the Y values, all the GPAs, and they came up with a mean for those. They called that Y bar, the mean of all the Y values. And that came up with the average GPA was, what was it, 2.63. And the standard deviation, they called it SY, was 0.58. So that's the information they got there. And they also got a correlation coefficient in R of 0.19. So they had these 5 bits of information, and we could actually use, if all we had was this information, we could use this stuff to come up with the regression line. Now I know what you're saying, well, they already punched this stuff in the calculator and it gave them R, so that means it also gave them the line. That's true, but we can kind of verify that it works with this with these formulas. So remember the regression line looks like this: y equals a plus bx. So what we need is an a value and a b value. That's what we kind of have to find. It's always going to have a y and an x in there, just like in college algebra. But we need to find this a and b value. And here's how we do it. The b value, we take r times sy over sx. So the correlation coefficient times this fraction sy, the standard deviation of the y's, divided by the standard deviation of the x's. We do all that math, that'll give us b, the slope. Once we have that, then we can plug that in here to find a. A, we take y bar, the mean of the y's, minus b, the number we just found, the slope, times x bar, the mean of the x's. And that'll give us our a. And then we can find our, we can write it in this format, and that'll give us our equation. So let's plug in some values and see what happens. Let's find b first. So b is going to be equal to r, which is 0.19, times sy, which is 0.58. Sorry about that, guys. Divided by 66.5. So that's sy over sx. So let's do the math and the fraction there first. So it's going to be 0.58 divided by 66.5 equals a big crazy decimal. And then I'm going to take that crazy decimal. This is what I got. I got 0.0087 and some change. I'm going to multiply that now times my 0.19 times 0.19, and I get this. I get 0.001657, and it keeps on going after that. But I'm gonna stop there, and then I'll round it off at the end over here. So I'm gonna use that as my b value. So that's gonna get plugged in over here. So that's my b over here. So now I have all this about all these things too. I have y bar. Y bar is up here is 2.63. So 2.63 minus b, this number I just got, 0.001657 times x bar, which is a 649.5 up here. So let's do some of this math over here. So let's do, make sure we do this correctly here. So let's do 0.001657 times 649.5, and I get a number. And just to kind of show you a little trick here, so I've done the multiplication here, but I have to do 2.63 minus what I just got. So a little trick you can do here is I can do my 2.63 minus, and then down here on the negative sign in the blue it says answer. I hit second and answer, and so I'm going to say this number minus whatever my last answer was equals. There we go. So I got 1.554. 1.554. And now that's my A value. Alright. So now I can write my regression line as y equals 1.554. B is a positive number over here, so plus 0.001657 x. So there we go. That's our regression line. We could, if we wanted to, we could write this, because they're writing with the words predicted and stuff. We can say predicted. The y's were the GPA, so predicted GPA equals 1.554 plus 0.001657 times SAT score, and that would be our regression line. So using this as an example, take a look at number 423. It starts on page 175. It kind of bleeds over onto 176 though. So give that a shot. There's parts A through D, I believe it is. But try them all out and let me know how it comes out.